Hi, welcome back to Algebra 1 Semester 2. This is day 10. The topic today is I can use multiple strategies to factor algebraic expressions. The first strategy we're going to look at is called difference of squares. But to begin, I'd like for you guys to pause the video and try the warm-up. Go ahead and multiply those together, simplify the polynomials, and we're going to look for some patterns as we do that. So pause the video now, try the warm-up, then come back when you're ready. All right, let's take a look. Remember when we were multiplying binomials, we started with the first terms in each expression. So the first times the first is x squared. Then we did the outsides, which gives us negative 4x. The insides is positive 4x, and then the lasts is negative 16. Combining the middle two terms, negative 4x and positive 4x add to 0 x's, so we don't even need x's anymore, and we get x squared minus 16. Let's look at the second warm-up there. The outside, or the first terms, gives us 25m squared. Outsides is negative 5m, insides is positive 5m, and the lasts gives us negative 1. Notice when I add those two middle expressions together, we're going to get 0 again. So we get 25m minus 1. M squared minus 1, sorry. Okay, again, let's look at the third example. 2a times 2a is 4a squared. 2a times negative 3b is negative 6ab. 3b times 2a is positive 6ab. And positive 3b times negative 3b is negative 9b squared. Those middle terms match and have opposite signs, so they're going to add to 0. So we get 4a squared minus 9b squared. These products over here give us a result called a difference of squares. Notice that the first terms are all square numbers and the second terms are all square numbers, and we're subtracting between them. So, the steps to factor a difference of squares problem. First, make sure that you have an actual difference of squares. Everything has to be a square number, and there must be a subtraction sign in between the two terms. Then we use the following rule to factor. So when you get a squared minus b squared, that factors into a minus b times a plus b. Notice that these are the square roots of the numbers in our original expression. So we have to take the square root of the first minus the square root of the second times the square root of the first plus the square root of the second. I'm going to do a couple of examples with you so you can kind of see how this works. N squared is a square number, and 64 is 8 squared, and we're subtracting in between. So one way to kind of write this is to write this as n squared minus 8 squared. So you can see what that a and that b term are, and then you can use that to help you factor. So we would take the square root of the first minus the square root of the second times the square root of the first plus the square root of the second. This is a really helpful trick to use, especially when you only have two terms and you do not have a common factor. So this is a way to help break down some of those. All right, let's do number 6 as an example. Okay, 1 is 1 squared. 49 is 7 squared, and y squared is y squared. So this is 1 squared minus 7y squared. So my first term is 1, and my second term is 7y. So this becomes 1 minus 7y times 1 plus 7y. Okay, let's take a look at number 8. 25 is 5 squared. So the first term becomes 5x squared, and the second term, 49, is 7 squared. So we take the square root of the first minus the square root of the second times the square root of the first plus the square root of the second. Okay, we can do this even when we get multiple variables. We just have variables on both terms. Both the first and the second terms have a variable. That's totally okay as long as those are even powers. So 64u squared would be 8u quantity squared minus v squared. So we take 8u minus v times 8u plus v. Now you can always check to make sure that your answers are correct by redistributing and remultiplying that out, just as a double check. So if we go back up to number 2 and take n times n, we get n squared. N times 8 is plus 8n. Negative 8 times n is negative 8n, and negative 8 times positive 8 is negative 64. The middle terms match, so they would add to 0. And that's a way that you can double check to make sure that you've got the right answer. On this page, I would like for you to complete problems 1, 5, 7, and 11, and then you can move on to the next part of today's work. All right, we're now going to look at factoring trinomials of the form x squared plus bx plus c. In this particular form, by the way, trinomial, tri means 3, nomial means parts, so this has 3 parts to the expression. So let's take a look at the warm-up. Take a few minutes, pause the video, come back when you're done, try the warm-up, and then we'll talk. All right, so let's talk through the warm-up. We're going to multiply these together. Remember, we can take the first times the first, so x times x is x squared. The first, so the outsides, so x times 5 is 5x. The insides is 1 times x is x. And then the last is 1 times 5, which is 5. Combining those middle terms that have both x's, we get x squared plus 6x plus 5. Okay, let's look at the second example. M times m is m squared. M times 6 is 6m. Negative 4 times m is negative 4m. And negative 4 times 6 is negative 24. Combining middle terms, we get m squared plus 2m minus 24. Okay, let's look at the third warm-up. K times k is k squared. K times negative 3 is negative 3k. Negative 7 times k is negative 7k. And negative 7 times negative 3 is positive 21. Combining the middle terms gives us k squared minus 10k plus 21. Trinomials like these can be factored back into a product of binomials. A couple of things to remember. When we're factoring this trinomial, you have to find two integers. Integers are whole numbers that add to b and multiply to c. Okay. By the way, this is where you learned how to use the generic rectangle and the diamond problem. So when we do these in your diamond problem, c goes on top, B goes on bottom, and we want to multiply to C and add to B. So for our guided example here, we have x squared plus 7x plus 12. So 7x is B and 12 is C. We want to multiply to 12, but add to 7. So we need to look at the possible factors of 12. Well, 12 could be 1 times 12, 2 times 6, or 3 times 4. And we want to look for a number that's going to multiply to 12 and add to 7, which would be 3 times 4. So those would be the solutions to the diamond problem. If we take our diamond problem and take it to the generic rectangle, we want to use our original expression. So we have x squared plus 12, and then we have to figure out how to split up that 7x. Well, that's the purpose of the diamond problem. So that means we're going to have 3 x's and 4 x's. Then we can factor each row and column of our table. So x squared and 4x, if I pull out this way, have an x in common. Then I can divide to find the bottom. So x squared divided by x is x. 4x divided by x is positive 4. Then I can factor each column. So if I pull out the x out of 3x and x squared, I get positive 3. And I can double check. Positive 3 times positive 4 is positive 12. That gives us a product of x plus 3 times x plus 4. So what two integers have a product of 12 and a sum of 7? That would be 3 and 4. Once you've distributed, then you can, once you've factored it, you can distribute back to find your answer. So x times x is x squared. X times 4 is plus 4x. 3 times x is plus 3x. 3 times 4 is 12. My middle terms add to 7x, which matches the original expression. So we know we factored it correctly. All right, let's do a couple more examples so you can see how they work. We want to multiply to 20 and add to 9. Well, 20 is 1 times 20, 2 times 10, 4 times 5. 4 times 5 multiplies to 20 and adds to 9. So those would be the answers to my diamond problem. Now, as long as there's no number in front of x squared, the solutions to your diamond problem are always going to be your the parts of your product. So you get x plus 5 times x plus 4. The order you write those doesn't matter because multiplication is commutative. We can do it in any order, but we can multiply back out to double check our work. X times x is x squared. X times 5 is 5x. 4 times x is 4x. And 4 times 5 is 20. And my middle terms add to 9. So that works just fine. Okay, notice that my problem had n's in it and I used x's. They work exactly the same way. So we probably should write our answer in terms of n, just because that's what we started with. So this would be n plus 4, n plus 5, to give us n squared plus 5n plus 4n to give us 9n. Okay, really the variable you use doesn't matter. It's just a good idea to match the problem. All right, let's take a look at example number 4. Okay, go ahead and build your diamond problem. The last number goes on top, the middle number goes on bottom. This one's kind of tricky because the only way to multiply by 1 is 1 times 1. Well, that works pretty great because that also adds to 2. So my binomials would be x plus 1 and x plus 1. Now, when those binomials match, that means that we can use an exponent to represent that information, and we get x plus 1 squared. All right, I want you to pause the video and try problem number 5. When you're ready, come back, we'll double check and we'll talk through it together so you can make sure you're on the right track. So, pause the video now. All right, let's talk through number 5 together. So, we want to multiply to negative 18, add to positive 3. Now, when the signs are, or when we have a negative number, that means that we're going to be looking for a difference. One of our numbers is positive and one of them is negative. Since our sum is positive, that means that our bigger number is going to be positive and our smaller number is negative. So we could do negative 1 times 18, negative 2 times 9, negative 3 times 6, 4 doesn't work, 5 doesn't work. If we look at negative 3 times 6, that adds to positive 3. So my binomials would be x minus 3 times x plus 6. It's a good idea to always double check. X times x is x squared. X times 6 is plus 6x minus 3x minus 18, which gives us x squared plus 3x minus 18. We weren't using x's, we were using n's. So change everything to an n, and you're good. Okay. All right. Your task for this page is to do problems number 3 and 7. When you're done, upload pictures and you'll be good to go. All right, page 72 is our last video, or our last page for today. There's just 2 more examples to look at. So let's look at example number 9. For example number 9, we want to multiply to negative 3 and add to negative 2. Now, my product is negative, which means we're going to have one positive and one negative when we're multiplying these together. And since my sum is negative, that means that the bigger number has to be negative in our multiplication. So negative 3 is 1 times negative 3, and that adds to negative 2. So we have a positive 1 and a negative 3. We're using the letter A, so this would be A plus 1 times A minus 3. Multiplying to double check, we get A times A is A squared. A times negative 3 is negative 3A. 1 times A is A. 1 times negative 3 is negative 3. And those add to negative 2A, which means that our product was correct. All right, one more example for us to talk about together. In number 13, notice that our product, that 24, is positive, which means that the signs have to match. But because my sum is negative, that means both numbers are going to be negative when we're adding these together. So to multiply to 24, I could take negative 1 times negative 24. Negative 2 times negative 12, negative 3 times negative 8, and negative 4 times negative 6. We want to add to negative 11, so that would be 3 and 8. So negative 3 and negative 8 would be my answers. My product would be x minus 3 times x minus 8. My outsides is negative 8x. My insides is negative 3x, which adds to negative 11x. And the last numbers multiply to positive 24. So we're good and we check out. Okay, on this page, you need to do problems 11, 15, 17, 19, and 21. When you're done, submit your work. Thanks for your hard work. I appreciate you guys sticking through this. I know it's a challenge to do this from home. Please reach out if you need help. I'm happy to help in any way I can. Thanks, guys. Good luck.